This is the Honors Pre-Calculus 2013 exam review question number 40. So number 40 says, find the missing parts of the triangle. Find angles to the nearest hundredth of a degree. So they give us AB, AC, and BC. We need to know what we're going to do with this given information. What we have here is three sides. And another important thing to notice is we have no reason to believe that this is a right triangle. So we won't be able to use SOHCAHTOA, we won't be able to use Pythagoras theorem. We want to be thinking law of sines or law of cosines because we don't know if it's a right triangle or not. So let's write down our given information, and maybe we'll make a little sketch. So we have one side that is kind of long compared to the others, is 320. And then we have one side that's 186 and one side that's 166. I don't really know the details of what it looks like, but I'll just draw something like that. So one thing I want to know is that a triangle always has 6 parts to it. When it says find the missing parts, what does that mean? Which parts are missing and which parts are we talking about? So a triangle always has 6 parts. It has 3 sides, which we usually call A, B, and C, little a, little b, and little c, and 3 angles, capital A, capital B, and capital C. And it's just a tradition that we use small letters for sides and large letters for angles. And I usually lay this out first anytime they give me the direction, find the missing parts of the triangle, because this helps me organize and make sure I've got all the parts. Now I can fill in my given information. I'm given that the sides are 166, 186, and 320. Now it doesn't matter which of these sides I call which, because there's not a hypotenuse to this triangle, because it's not a right triangle. So the A, B, and C are interchangeable. But once I pick what the A, B, and C are, to use my formulas, I need to decide how have I laid out the triangle then. If small a is the 166, then this must be small a, and this must be small b, and this must be small c. Now for all of our triangle formulas, the angles are across from the sides that are given. So if this is side small a, this is angle capital A, this must be angle capital B because it's across from side B, and across from side C we must have angle C right there. So these are our angles. Now we want to look at our given information and notice that we have information given in the form of side, side, side. And anytime that we have side, 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 or side, angle, side, in these two cases, we want to be thinking about the law of cosines. And so if we had different given information than this, we would think about the law of sines. Now, once we've decided that it's law of cosines because we have side, 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 then let's go ahead and write the law of cosines. So the law of cosines says that small c squared equals a squared plus b squared minus 2ab cosine c. These should be small a's and b's, so I'm just going to rewrite that. We have c squared equals a squared plus b squared minus 2ab cosine c. This is not too hard to remember because this part looks like Pythagoras theorem, right? A squared plus b squared equals c squared. Then we have this correction term. It involves a cosine because it's the law of cosines. And then we just have to remember that this angle matches this side and these two sides match these sides. However, this will be one of the formulas that is given to you on the test, so you don't have to memorize this one. It's a good one to know though. So there's what we have, and we're going to go ahead and fill in our given information. So our given information is these 3 given sides. So we're going to put in 320 squared equals 166 squared plus 186 squared minus 2 times 166 times 186 cosine of, now the angle C is what we're trying to find in this formula. So we had our given information matches this, 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 and this, but our cosine C is what we're going to solve for first. So let's go ahead and solve for C. The first thing we need to do is square out all those numbers, and they're big and obnoxious. So we have to do 320 squared, and that turns out to be 102,400. So you might recall, you tend to get big ridiculous numbers here. And then we've got to do 166 squared. So 166 squared. And that's 27,556. 27,556 plus our 186 squared. So that's 186 squared. And that's Well, that looks a little large, doesn't it? Let's try again. 186 squared, and that's 34,596. So 34,596. And then let's go ahead and multiply these three numbers together. So I have 2 times 166 times 186. 2 times 166 times 186. And that equals 61,752. 61,752 cosine C. Now, one important thing we need to do next is we're going to combine these two terms, but a common error is to combine all three of these terms. We cannot do that because this term is cosine C, but these terms are not cosine C. So these terms are going to combine, but this one has to wait out till the end. So we're going to copy down our 102,400, and we're going to combine these two. So I have 27,556. So 27,556 plus our 34,596, 34,596, and that equals 62,152. 62,152. And we have minus 61,752 cosine C. The next step is that we're going to subtract this from both sides. So we need to get this, we're getting like terms together. So we're going to go minus 62,152 from both sides, 152. We're going to subtract that from both sides. So over here on this side, I can just do that. 102,400 minus 62,152, and we get 40,248. So 40,248 equals negative 61,752 cosine C. Now, one important thing is an important check on our work at this point. Cosine has to be less than 1. And so one thing we want to look for is this number must be greater in magnitude than this number so that when I divide it, we'll get a number less than 1. So I see that the absolute value of 61,752 is in fact greater than 40,248. So that means I can go ahead and divide by that. And it doesn't matter that it's negative. We'll just divide that out. 61,752. So that means that I'm now doing 40,248. 40,248 divided by 61,752. You might notice that when I'm doing calculator work, I tend to leave the negative signs out just to make it quicker on the calculator, and then I'll put the negative sign in because I know that the positive divided by negative is a negative. Typically when we do law of cosines, we want to keep about 4 decimals here. There's nothing important about that rule, nothing critical, but it's what I like to do. So we're going to call this 0.6518 because 6 is more than 5, so we're going to round the 7 up 1. 0.6518 negative 6518, and that equals cosine of C. So now if I want to know what angle C is, I'm going to do inverse cosine. So the inverse cosine of negative 0.6518 equals C, equals the angle C. So in order to do that, I need to check to make sure my calculator is in degree mode if I want degrees, and radian mode if I want radians. So let's look back to our angles, our directions. It says find angles to the nearest hundredth of a degree. Since it's degrees, we want to make sure our calculator is in degree mode. And throughout the exam, you want to pay attention to when we're looking at information in degrees, when we're looking at information in radians, and make sure your calculator is in the right mode. This problem calls for degrees, so we need to make sure our calculator is in degrees. Now if I look at my calculator, it seems to be in radians, so I need to change it. So I'm going to go to my setup, I'm going to go down to angle, and I'm going to pick degrees and enter. So now I'm in degrees. I'm going to clear out that number that I've got there. Now I'm going to do the inverse cosine, so inverse cosine of negative 0.6518. And that is 130.67. Now it said nearest hundredth of a degree, so we're going to call that 130.68 degrees. So that's 130.68 degrees equals C. So now I've found angle C to the nearest hundredth of a degree, and I might, if I'm good at sketching triangles, and I paid attention to the fact that 320 is just a bit more than 166 plus 186. So I know that this triangle is kind of flat, and so it makes sense that this should be an obtuse angle. If you can check a little bit like that, it's helpful. All right, so now I've got angle C, and since I've got that, I can fill it in as one of my pieces of given information. Angle C is 130.68 degrees. Now I still have to get angle B and angle A. So the first thing that I'm going to do is get angle B the same way that I got angle C. Now, by the way, you have options. You could also get angle C by law of sines now, angle B by law of sines. In fact, law of sines might actually be easier since law of cosines has all these big squares and things. We have the option to do law of sines to get angle B because now I have an angle. So before all I had was sides, so I had to use side, 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 so I had to use law of cosines. But now I've got an angle, so I could take advantage of the fact that angle C and side B and C give me a side, and an angle, and I could use law of sines to find angle B. So let's do that. So now we're going to do our law of sines. Let's see, let's make sure I can see my given information here. So put it right there, and we can see, I think, everything we need to see. So let's try doing B over sine B equals C over sine C. So B over sine B equals C over sine C, and that will allow us to find angle B. So now we can plug in our given information here. We have, for our B, we have 186 over our sine of B, so that's sine of, the angle B, we don't know what it is. And that equals our C, which is 320, over the sine of C. That's the sine of, we know what angle C is. It's 130.68 degrees. All right. So now I have a proportion and I can solve it. So the proportion is easily solved. You can do a cross product, but I usually take a shortcut of just going, I'll just take this number, these two diagonal numbers and multiply them. And then I'll take the leftover number and divide it. So what I'll write is 186 sine 130.68 degrees divided by 320, and that's going to equal sine of B. Now this I can just put into my calculator just like that. So I can just put in 186, oops, that doesn't look like 186, 186 sine of 130.68 divided by 320, and I get 0.4408. So again, when you get a number that is supposed to be a sine of something, it's important that this number has to be less than 1. So we're happy to get a number that's less than 1. It means we're on the right track. We don't have a no solution or something like that. So what we have is our 0.4408, and again, I like 4 decimal places for trig functions, equals sine of B, and therefore B equals the inverse sine of 0.4408. So now let's use our calculator to find out what that inverse sine is. So if I do inverse sine of that previous answer, that is equal to 26.15. So I got 26.15 degrees, remembering again that the directions asked me to round to the nearest hundredth place. 26.15 degrees equals B. Now again, if I've drawn my triangle reasonably, this should at least look like it's an acute angle. My angle B does look like it's an acute angle, 26.15 degrees, so I'm reasonably confident that this is in fact my angle B, which is 26.15 degrees. So that's what I'm going to put here for angle B, 26.15 degrees. Now, I would be crazy to use law of sines or law of cosines to find this last angle, and I'm not crazy, so far as I know. Some people have cast aspersions, but I'm pretty sure they're wrong. What I want to do is go back to the fact that I know that the angles of a triangle add to 180. So we know that A plus B plus C equals 180 degrees. And our A is unknown, our B is 26.15 degrees, and our C is 130.68 degrees. So what some people will do here is just add these two angles and subtract from 180. That's fine, you can do it that way. I'm just being nice and writing out the algebra. So A is 26.15. So we have our 26.15 plus our 130.68, and that gives me 156.83. So 156.83 degrees equals 180 degrees. Now I'm going to subtract the 156.83 degrees from both sides, minus 156.83 degrees. And I get that A equals 180 minus my previous answer. So 180 minus that last answer is 23.17. So my final answer here for angle A, 23.17 degrees. You probably could do that a little bit more efficiently. I'm just really writing out all of the steps to be extra careful. So this is my answer to that part, 23.17 degrees. So now I can look over my complete answer here, which is this information. So the problem asked me to find all the missing parts, to find the missing parts. So it said find the missing parts of the triangle. So what I did to make sure I didn't miss anything is I laid out all the parts of the triangle. So I've got 3 sides and 3 angles, and I made sure I filled in all the blanks, and I followed their direction, which said find angles to the nearest hundredth of a degree, and they are all to the nearest hundredth of a degree, so I've got that one right.